we will start. Hello, everyone, and welcome to our Rutronik webinar series, Rutronik Connects. My name is Tobias Lusch, and I'm a corporate product manager within the wireless department. This week is all about cellular and GNSS, but there are more to come. I will tell you later. Today, I want to welcome Jens Kattenbusch from KYOCERA AVX, our long-term partner for wireless parts, with the topic about designing multi-band antennas for small IoT devices. The duration of our webinar will be 45 minutes. Questions are, of course, welcome. You can type them on the right sidebar. We will tell them afterwards. If you have more questions, you can contact us afterwards, of course. I will tell you my contact information later. The presentation and the slides will be recorded, and we will send you them afterwards after our webinar. Also, this I will tell you later. So, hi Jens. Welcome to our today's webinar, and I want to hand over to you so you can start and have fun, everybody.
Yeah, thank you, Tobias, for the warm welcome, and also welcome from my side. I hope you can see my screen. So, yeah, as Tobias already introduced, today I'm going to introduce to you our antenna solutions, especially for smaller IoT devices, trackers, etc. My name is Jens Kattenbusch, and I'm the Regional Technical Sales Manager for RF and antenna products at KYOCERA AVX. I'm located in Germany and always welcome you to take our support and make the best out of your device. So a little bit of background from KYOCERA AVX. Here you can see some of our key applications. So especially in Europe, we are quite strong in the automotive and industrial sector. In other areas, we are very strong on gateways, routers, and mobile communications, wearables, etc. And generally, we are focused a lot on design in and custom solutions with our own patents. We support global projects with our 25 measurement systems. I will also show you the locations where we are on the next slide. And we support passive active antennas, measurement systems, services, everything related to antennas. So here you can see our main facilities. So for Europe, our global headquarters for antennas is in France, close to Nice. We also have an office still, design center in San Diego, and multiple ones in Asia, including our 3 factories in Korea, Vietnam, and China. The focus applications for us are generally IoT, industrial IoT, industrial gateways, wearables with mostly custom antennas, satellite communication, automotive and asset tracking, smart homes, smart metering. And in many of those applications, the product size is usually quite small. So multi antennas are integrated, and this needs some considerations to make in order to choose the right antennas and to optimize the whole system. So we have a lot of standard antennas that already work very, very well in most of the scenarios. But if the design is more complex, we also do custom designs and customize our current antennas to customer needs and customer requirements based on different factors that are needed to be adapted. And also we do services, validation, and pre-certification, so that you can make sure to pass the CE FCC certifications, for example. So as already mentioned, there are multiple factors for IoT devices, especially. Usually they're quite small, so we have a very compact design, very low profile. They're highly integrated and lightweight. They have to be reliable. A reliable connection to the base station, for example, to the satellites, to whatever is needed, to the phone maybe, low power, high accuracy, and very efficient. And of course, for many devices, the coverage should be global. Usually there's also a local connection involved, as we will discuss about Bluetooth and Wi-Fi later on. But also satellite communication is growing more and more. We already have some antenna solutions for that, just to make sure not only on land, but also, for example, on sea or in areas that are not well covered and all over the world, the devices will work. So we will focus a little bit more on the NB-IoT, cellular part, GPS and BLE Wi-Fi for this webinar here. And first of all, I want to show some of our standard cellular low power wide area network antennas. We have a lot of different solutions here, starting from SMT type solutions with different form factors, having a very unique tuning optimization technique. So it's possible to tune the upper and lower frequencies separately and still have the antenna matching as well separately. So it's really possible to optimize the antenna throughout the whole frequency range and exactly to the application. Why that's needed, I also have some slides later on. Usually there's a small frequency shift, but I don't want to give away all the updates here. We also have some vertical PCB mount antennas and of course our standard FPC PCB type antennas. So part of them are flexible and part of them are rigid, so you cannot bend them. But typically for cellular we offer the flexible PCB type antennas with custom cables. So in each of our data sheets there's different cable lengths and connectors that you can choose from as a standard component already as well. Then we have our external antennas, which is divided by indoor and outdoor antennas. The outdoor antennas usually have IP67 rating. A few of them only IP65 or IPX7, so not tested for gas, but tested for water resistance. Another highlight of our portfolio is our active band switch. This is our EC696. As you can see here, it's pretty small, together with one of our LTE antennas. This is even our smaller LTE antenna that we can offer. The device itself, it's just 1.1 by 1.5 millimeters in size, and the benefit is quite huge. It's a 4-pin GPIO SP4T switching chip, reducing the losses internally. So it's possible to increase efficiency, the overall efficiency of the antenna by around 10 to 20% or more, depending, of course, always on the layout. We have an eval board that you can test right away, together with our antenna, of course. So it comes with antenna, switching chip, and a SMA connector to test right away. And especially for smaller IoT devices, we always recommend to use it. It's a super small part. It will fit on a small design usually. And yeah, if you need some samples, feel free to contact Rutronik or KYOCERA AVX. And just some nice samples we developed together with Nordic Semiconductor. First is our LTE antenna, GPS antenna, and the switching chip for a super small NRF91 design. It's 53 by 53 millimeters, covering the lower bands, middle bands, and GPS, of course. And also with our switching chip, we can improve the efficiency in all of these different frequency bands. Another solution we made was the design for the Nordic eval kit for the NRF91 60, 61, and 51, covering the same frequencies for cellular plus DECT NR plus, which is a short range to mid range technology, coming also more and more based on the 19 megahertz, 1900 megahertz bandwidth. If you want, you can check it out. We have a special data sheet for that on our website, which is available in the presentation once shared after the webinar. So the next technology highlight, I would say, are the BLE and Wi-Fi antennas. We have some ultra small parts for the chip antennas. We have some bigger form factors which need less ground clearance usually. And having such a huge portfolio of different antennas, we can always find a solution that fits somewhere on the PCB. If it is the corner placement of the top antenna here, or on the side of the longer edge on the other antennas, or different positions, for example, with our metal stamp antennas. The metal stamp antennas also have the advantage that they are three-dimensional, so you can cover quite well a three-dimensional field, and especially with metal environment in the surroundings, this can help to improve the performance a lot. Also here we have our external antenna and FPC PCB type antennas. For external we have also different mountings, so usually SMA or RP-SMA, but also we have one type with a UFL connector right away that you can just plug into your device through hole. Typically the antennas all cover Bluetooth and Wi-Fi 6E or 7, so some of them also support the 7 GHz band in Wi-Fi. Similar for our FPC PCB type antennas, of course. We have some new families here released recently just to improve the performance, but we still remain our older versions available, because even though they are a little bit less performing, the main advantage is that with certification there are some restrictions in peak gain, for example, and the previous versions, they are of course much more suitable for these applications. But if you want to have an optimized part, our new versions are the way to go with. And maybe a small highlight here is our on-metal antenna. So this one is really stick to some metal surfaces and directly connected to the PCB. Another highlight is our multiband chip antenna here, which can be used for BLE, Wi-Fi dual band, so 2.4 and 5 GHz plus ultra wideband. In a super small design, it's 1 by 0.55 millimeters, reaching quite good performance, I would say, overall. And the clearance area is also not too big. You can find all the information in our data sheets or application notes. Usually we also have our 3D files and HFSS files available on the website as well. Also, of course, eval boards in case of some tests you want to make. Feel free to check out the eval boards. The next part are the GNSS antenna for positioning of the device. And here it's quite difficult to distinguish between the different requirements that are maybe required. So we have one for all is the directivity. So we offer omnidirectional chip antennas, for example, that are much better covering the surroundings overall. Or we have the directive ceramic chip antennas that are quite strong in one direction. But if the device is tilted to any direction which is not facing the satellites, the omnidirectional linear polarized antennas are usually much better to go to. And of course, also because they're smaller and fit to smaller designs usually, and also lighter because they have the bigger ceramic patch antennas, which main materials are ceramics, which is quite heavy. The second thing is the polarization that's causing the directivity of the antenna. And also here we have already some stacked patch antennas for multiband GNSS applications, even smaller ones. So the one that you can see here in the upper left on the middle part is a super small antenna, quite lightweight for what it can do. And in the bottom you can see different linear polarized antennas, SMD type, the chip antennas, FR4 material, and metal stamp antennas. The next thing to think about is if the GNSS antenna should be active or passive. With passive antennas, usually you have to design the LNA network, matching network yourself and connect it to the module. With active antennas, the LNA is already integrated, so you can just plug it in and use it for your requirements. Also here we already have a brand new dual band patch antenna, L1 and L5, integrated with LNA already. So another highlight is our 1,047,095 antenna, which is a all-in-one antennas for most IoT requirements. As you can see in the top, we can cover the LTE 450 megahertz band, LoRa, ISM 433 megahertz, ISM frequencies 868, 915 for LoRa, etc. GPS, DECT, NTN satellite, Bluetooth and Wi-Fi, and of course also cellular. With this design, it's a quite small antenna, 36 millimeters in size, so it's not super big for an LTE antenna that can do this much. The best way to use it is usually for cellular, but as said, you can use it for everything else as well. And if there are questions regarding the tuning, also here, please feel free to contact us and Rutronik. To give some example on the differences and the performance differences of the antennas and of the type of antennas to choose, we took an example for real-time kinematic RTK systems, which is a high-precision GNSS technology, which is a combination of satellite communication, but also fixed base stations, which have a predefined location, and both signals are received by the rover, which then can calculate the exact position in centimeter level positioning. So we are really talking about a few centimeters only, depending on, of course, the antenna. And what we did was some tests with an eval kit for an RTK system, with our chip antenna, with a passive patch antenna, and with an active patch antenna. And the main factors that we measured were accuracy estimation and time to first fix. So we can see here it's around 4 centimeters, around 6 centimeters and 3 centimeters in the accuracy for the position, which is already quite good, but you can see also the active patch antenna is the most precise here. So with the biggest design, you have the biggest performance actually. But of course, the ceramic chip antenna is also quite well for being such a small product. The other thing is the time to first fix, and also here the patch antenna, the active one, is much better compared to the other ones. And here you can see also the main disadvantage of the ceramic chip antenna, because the time to first fix is the lowest one in this comparison. If you need more information here, please also feel free to contact us. And next question will be, generally speaking, what kind of antenna is required for the application? So we saw that it makes a difference. And the first question to always ask is how many technologies must be integrated in the device, if it's just cellular and GPS, or cellular GPS Bluetooth, or cellular GPS Bluetooth ultra-wideband. The number of technologies is almost unlimited, it feels like. Second question, what frequency bands must be covered for each technology? Size of the PCB, what is the space available for the antennas? Is it an onboard or offboard antenna, or external antenna maybe even? What are the antenna surroundings directly on the PCB in the application, but also in its typical use case? and what is the end user environment. So also if it's a hand-worn device or body device or in open space. And for this, we have some nice tests we did, some few slides to show why it is important to exactly calibrate your antenna to your device. So first test we did was a size effect of the PCB. So we took one of our standard cellular antennas, and this is our recommended PCB length, in this case 110 millimeters. And we reduced it step by step to 50 millimeters in size, so around 55% reduction. And especially here in the lower frequency range, we can see a similar loss in efficiency. Of course, efficiency is not always everything in terms of antennas. There are also other factors that needs to be considered, like the gain, for example, or the VSWR, but efficiency is overall the most common factor to compare when it comes to antennas. Interestingly, on the mid-frequency range around 2000 megahertz, so also similar for Bluetooth and Wi-Fi, for example, the frequency of the smaller device is actually better. So also here you need to consider if the cellular connection is the main connection to go with, or for example Bluetooth. Based on that, the antenna PCB may be smaller, or if you have to focus on the cellular part, the antenna size should be longer. Another effect we measured was the placement of the antenna. So typically for most products, and especially in cellular, we have mirrored versions. So the pin layout on the backside of the antenna is mirrored. So you can use it either in the upper corner on the top left or in the bottom right. Also in the center or in the other way around. And on the right side, you can see we did the tests placing the antenna in different ways. And here, for example, position 1 on the top left corner and position 2 in the exact center of the PCB. And also here, of course, the performance drops drastically when the performance or when the placement is not set to the optimal position for this antenna. So please always take a look at the design in the application sheet or in the data sheet to follow these guidelines in order to have the maximum performance. But also here, all of these antennas are measured on different PCB sizes because that's typically the optimum for each antenna. So for the slightly smaller cellular part, the PCB size is 125 by 45 millimeters, and actually for a little bit bigger part, the antenna the PCB size is 140 by 50 millimeters. So that's also always needs to be considered. And if you reduce the PCB size as shown in the previous slides, of course the performance will also drop. For cellular, please never locate the antennas on this longer edge of the PCB or in the middle of the board. As we can see here, that typically doesn't work out well. Another topic is for Bluetooth. So typically Bluetooth and GPS antennas, the linear polarized chip antennas, are mounted exactly here. So that always needs to be considered and is always shown in the data sheet of our products. Another test we did was the environment test. So first having human absorption. And as we can see here, there's a big delta gap in these TRP measurements. Whether it's in free space or beside a human head. So we have this test head in our lab that we can always use for these kinds of measurements. And that's why there are several regulations if it's a product that is within 20 centimeters range of the body or outside of these 20 centimeters of range. Secondly, material of the surrounding areas or the housing, for example, also makes a big difference. So we tested our antenna on glass, plastic, and in free space. And the main factor that appears here is not losses in the performance, but a frequency shift. So here we can see the antenna is tuned to a plastic carrier, plastic housing where it's sticked on. And if it's in free space, even the frequency will shift to the right, 600 megahertz. And if it's another material, like for example, glass in this case, the frequency shifts to the left, to the lower frequency range, around 300 megahertz. So also here that needs to be considered right away when using the antenna. We also have these metal antennas exactly for this reason, because they're perfectly tuned already for the metal environments. And in this case, this product that you can see here in the top, it's the same product for all these pictures, but this product series is a tunable antenna, so we can have some shorts and some resistors on soldered to the device, close some bridges here to detune and retune the antenna in the end. And this is done in our factory, so you first decide which products or which bridges have to be closed, or which shorts have to be soldered, and then we can produce it exactly this way, so you can already use it for the right frequency range and center frequency that is required. And all of these tests and services we offer officially through our website. So there's a part number for different tests and different measurements. And I would just like to go through it a little bit based on this slide. So the first thing usually when we have a custom part is the design phase. So we review customer requirements, check the layout, do some simulations if possible, if required, and start with a custom antenna design. For standard components, usually this falls off the list because we already have the product. In this case, then we just review the customer requirements and recommend the optimized antenna for exactly this requirement. We can still do the simulations based on the customer's layout and get to the next step, which is usually then for standard components on the customer side. If it's a custom part, we do the prototyping ourselves. So we have multiple different 3D printers, for example, for housings, for LDS platforms that we can use just to build a prototype for proof of concept, and otherwise building a mock-up in our factories. The next stage is the testing and optimization. So for fully custom parts, we do the testing in our chambers, doing the tuning, optimization, passive and active testing. And we can already do FCC CE pre-check to say, okay, the antenna in this environment, exactly on the application of the customer, will pass the certifications or not, or we see already some big changes, especially in the gain. That's the most critical part, where the antenna exceeds the required gain of the module already in the first tests. For standard components, we can always do that separately, but that's a test that has to be ordered separately then. And for standard products otherwise, we can still offer exactly these tests. So you can send in your application. You can send in first the PCB and later on the application with housing and everything. We always recommend, of course, to have the PCB plus housing all in one, that we can test it right away. The next phase is the validation phase or factory samples. So when we have the final samples approved, always very close working together with the customers, we can do some tuning and optimization as well on the matching network, for example. Finalizing the last bits of the product and create the factory samples, and then do test reports like, for example, PPAP, some medical requirements, etc., and then go to mass production. So it's a fully transparent process. You can go to our website and check our services at any time. And if you need an offer, we can always talk and discuss exactly for your application what will be the costs. It's usually depending on the design and the complexity of the product. And to show some of the customized parts we did in the past, we have multiple technologies that we can do. Mostly common for antennas is LDS and FPC or stamped metal. So the LDS products are here these metallized carriers which can integrate multiple antennas. So on this part we have at least 2 antennas. So one being the one on the top and one antenna here in the small free space here. So it's possible to integrate multiple antennas, and that's usually the case in smartphones, for example. There are more than 10 antennas in each smartphone, and these are all applied to such a plastic carrier with these metallized structures. And similar, we can do it for metal stamped antennas to just have a stamped metal part that will be integrated, for example, in such a plastic, or can be soldered directly to a PCB. A little bit easier for us is the flexible PCB design because we can do just tracing on the PCB part and the initial costs are much lower for such products. So we can recommend the FPC for around 20-50K pieces a year. LDS technology or the custom metal stamped we usually recommend for quantities higher than 100K pieces, just because the initial costs are quite high. We have higher engineering costs, higher molding costs, and higher tooling costs in general. But you can check out also the custom solutions on the website and reach out for questions. So here you can see some highlights that we do in terms of testing and specialty testing. So as I said already, we do FCC CE pre-checks. So we are not allowed as a manufacturer of our antennas to certify our own antennas, of course, but we can do the pre-testing and we can tell if the products are going to fail the certification or not. And then, of course, optimize it if that is required on your side, or you can do it yourself. We also do specialty testing like angle of arrival or angle of departure for ultra-wideband and Bluetooth. So especially interesting for indoor tracking. We have a 3D measurement chamber for that to also measure the phase variation for ultra-wideband and Bluetooth. We can do GNSS phase center measurements. This is what's shown here on the picture. So the black dots are the position of the PCB of the device, and the colorful dots around are the real measured accuracies for a custom application here. We also have a millimeter wave test chamber. This is mostly interesting for 5G millimeter wave and coming up 6G cellular. On the right side, you can see some 2D, 3D radiation patterns and especially combined gain. So the purple and green colors are 2 different antennas, and what we measure here is how they add up in terms of performance together in the MIMO system. So we can also do exactly these MIMO measurements, also MIMO throughput measurements. These are all available on our site. And what I wanted to show as well in this presentation is exactly a measurement we did with a customer. In this case, the main problem was not the performance of the antenna itself. The main problem was the harmonic waves that were created in the RF environment. And thus the customer failed the certification in the first trial. So the second resonance was quite high in this case, and what we had to do was to first do the measurements. In this case, unfortunately, after the customer already failed the certification once, so he always has additional costs just measuring everything again, going to the certification lab again, going to the test house again, having all the engineering work to rework the product and check what is even the problem here. And of course, maybe find a new product and certify a new antenna internally first. And that's why we offer exactly all the testing that we do offer. And in this case, after the customer failed for the first time, we were able to figure out what was the problem. We could adapt the matching network. And after that, the customer passed the certification. And coming to the end, I'm just showing some standard antennas which we designed in some custom applications. So here is fleet management, for example, with cellular and GPS in two different antennas. On the top middle, we have GPS, Wi-Fi and cellular on a super small device. So also here, as I said, this is one of our favorites to work on because it's not an easy design, but it's many antennas and it's a complex design because the PCB is just so small. Similar to the sheep tracker on the very bottom here, using NB-IoT and GPS. So the customer had to increase the size of the PCB in this case to properly fit the antenna here, because the NB-IoT frequencies in the lower frequency range require some space or some ground to be caught in the air. So that's why this design was also very, very interesting. And on the right side, we have a very rugged battery-powered GPS tracker as well, using LTE and GPS. And also here, the battery-powered, again, is a big factor here, because optimizing the antenna performance in the device will help you to reduce the battery usage and battery drain, because the performance is much more efficient and you don't have too much losses, just losing power, radiating like crazy in the air and just not work efficiently. Some custom antenna designs we did was also some pet tracker for dogs, in this case for an LDS design. So here we also have cellular and GPS. So the top antenna, the top antenna structure is the LTE antenna, and the bottom small part here is the GPS antenna. So also here the advantage of LDS, it's a super small design and multiple antennas in this housing here, which can be then integrated very easily, just plugging it into the customer's housing here, having some spring contacts, for example, and then customer is ready to go. So also in terms of assembly, LDS can be feasible, but as I said, the quantities should be high to cover the initial costs. Another nice example is this pigeon tracker. In this case, we didn't use LDS, but we used some FPC flexible PCB antennas using GPS here. So in this case, the antenna you cannot see here. It's in this clip and around this clip, also contacted with some spring contacts here. And another example is a people tracker application using multiple LDS antennas, in this case even for technologies in one device, plus a capacitive touch sensor, which is also done in LDS. So LDS can be also used for tracing, routing, and capacitive touch applications. So most of the information's, basically everything you can find online in our website, and all the standard components are in our tool search. We have a lot of reference recommendations for different chiplet module suppliers. We have a lot of sample kits and lab boxes available. Also here, please feel free to contact Rutronik and KYOCERA AVX in case you need any samples, any sample books, any visits, any support, that we can discuss all these topics together. We also work with the IoT solution optimizer where you can integrate, or where you can design your part online, kind of choose the different module, the different antenna, and of course different batteries, different additional products, applications that you need for your application. And it will calculate exactly what kind of battery lifetime you will have in the end. It will calculate what data plan you will need and calculate if it's for indoor, outdoor, or deep indoor applications, or if it will work or not. We also have all the design tools online, application notes, Gerber files, simulation files, etc., and additional resources like white papers, videos, recommendation guides, etc. So last but not least, a small summary, what we can do and what we are providing to our customers is, of course, extensive RF knowledge and experience. As I said, we come from more custom parts. Since the acquisition of AVX at the time in 2018, we built more and more standard components that we now customize and optimize for our customers. So we have a solution ready already most of the times. And if this solution is not enough, we can do customized solutions here, and especially challenging mechanics. That's our specialty. That's why we have a very agile team in France for Europe that will cover every application here. We have the services that we offer for validation, product review, layout review, simulations, etc., and up to pre-certification. And we have a very innovative roadmap with also fully custom parts that now become standard. So for this, I also recommend to check out the other webinars, for example, Ultra Wideband, where we introduce some of our latest product highlights that we developed and patented just for KYOCERA AVX. So that's it from my side. Thank you again, Tobias, for inviting me here to the webinar. Are there any questions?
Yes, thank you very much, Jens, for your amazing presentation and information. We have some questions. I will step in directly in the Q&A session. The first question is, do you need a larger circuit board for smaller chip antennas?
So that depends really on the technologies here. So as I've shown, especially for cellular, cellular sub-gigahertz frequencies, including 868, 915 megahertz for LoRa, for example, the PCB size does matter a lot. For other technologies like Bluetooth, like Wi-Fi or GPS, the PCB size itself is not that critical actually, and the position of the antenna is different for each antenna technology. So clear answer is it depends on the technology that is required here.
Okay, thank you. The next question is, how much time is required for the various measurements?
Also here, the easiest answer is, and the most true answer is, it depends on the measurements, of course. So some of the passive measurements we can do quite quickly, usually within 2 weeks, but more complex measurements, including some custom layouts or some customizations, they can take up to 4 weeks, depending on the availability of the measurement chamber. Usually we also have to create a rig where we can attach the device or the antenna to. For example, at the moment we have a very heavy device. It's a big metal housing where we need to create a special rig first to mount the device from the customer. But usually within 2 to 4 weeks, we can do the different measurements and have a full report available.
Thank you. The last question now is, which antenna type should be used for the simplest integration?
Also here, we usually recommend SMT antennas because they're usually the easiest and cheapest to go to in terms of product cost, but also integration costs, because they are soldered automatically in the SMT process. If that's not possible, the flexible PCB type antennas are the next easiest way to go with. You can just use your UFL connector or IPEX connector and just stick the antenna somewhere. But of course, that means manual labor. And the next stage would be external antennas, where usually you have an adapter cable that you need to mount first from PCB to housing, and then you have to attach the external antenna as well. So that will be the third step and the most complex step in terms of integration and price usually. So you need an adapter cable, you need the antenna and the UFL connectors, etc. But the easiest design is usually done with SMT antennas, and when it's a plastic housing and there's no metal in the design itself, that's usually also the best performing solution, because it's using the PCB ground plane as a radiator.
Thank you very much, Jens. These are all questions for now. If you have further questions, of course, please contact us. You can tell us afterwards, and of course, we will answer also afterwards. Just few slides from my side at the end. One moment. So I hope you all can see my presentation.
Yep.
If you want further information, please feel free to check our Rutronik.com, Rutronik24, and our Rutronik Tech website, where you can find all updates and new products. Also, you can follow us on social media, on LinkedIn, Facebook, Instagram, and YouTube, so you are always up to date. The presentation and the slides, as I told, will be recorded, and you will receive them afterwards. If you have further questions, don't hesitate to contact your local Rutronik sales manager or me directly. You can find my contact information on the left side. Or, of course, you can fill out a contact form you can find on Rutronik.com and on the right side. Here are all of our webinars from Cellular and GNSS. The next one will be this afternoon with Telecentarian and Adam Cousin with Just Plug In and Switch It On, IoT terminals and gateways. And the last one is tomorrow at 10 a.m. with Nordic Semiconductor and DECT NR Plus, the world's first non-cellular 5G standard. You're also welcome to join our next webinar series beginning on the 21st of October with the newest topics about ultra-wideband, LoRa, and other technologies. We'll have there our suppliers Infineon, Inside Zip, Ocean, Murata, Pulse, and of course again KYOCERA AVX on board. All the information about it can be found on our Rutronik webpage and will be shared within our social media channels. We'll be happy to see you there. Also, one further information from my side, we'll have a webinar in person with, for example, KYOCERA AVX on the 26th of November with the topic RTK. If you're interested, please feel free to contact your Rutronik sales guy or me directly. So thank you very much again, Jens, for your presentation and amazing information. Thank you everyone for your participation, and I would be happy to see you in our next webinars. Thank you everyone, and have a great day.
Thank you guys. Bye-bye.
Bye.